Hello, welcome back to BLENDERSUSHI Live Noding. Previously, we already saw one way we can generate like a level design just by drawing grease pencil and kind of making like intersecting lines, and then we're gonna do the same thing, but this time we're not gonna draw the lines procedurally. Actually, we're not gonna draw the lines manually. Sorry. We're gonna try to do it automatically, and we know that we have this space tree algorithm that's Elfnor made at some point. It's this one. It's from her GitHub. She also blocked this script at some point. You basically just download the zip, and then once you have this zip, you simply take a look and then load it inside Sverchok as a script node. Let me just copy that into the desktop, and there you go. Replace. Now let's switch to Blender and switch to compositing and turn on Sverchok Node 3 file, save as desktop, and Elfnor level. This is gonna be like a quick exploration. Hopefully this works fine for us. What we're gonna do is to generate some random points, random vector. Oh, actually, I forgot. We're gonna load the script first of all. So let's open a text editor and find the space tree Sverchok master. It's called treegenerator.py. So this script will work perfectly with Sverchok script node. Simply load it and plug. Now we have this node, and this node, I really like this node. It's super useful to make some kind of like a. This is one algorithm that will generate like if you have like a few ants or insects, this algorithm is kind of generating lines, kind of like that's behaving like insects. That's what I think. It's a bit like a tree as well. Okay, so we have random vector generator here, and we're gonna view it. First of all, by default, random points will generate random points, of course. You can see here. We know that we can now just flatten this guy simply by using vector rewire. So you see here x to z. So we can like rewire axis, but in this case we want to scale it to 0 in the z-axis, so we get like a flattened points here. So this is gonna be super useful for us. And this guy is going to be the end vertices. Okay, so that's the end vertices, and we also gonna have another random vertices, but this guy is gonna be our starting points, and we have 3 points for this one. Gonna randomize the seed again and plug this into the start vertices, and hopefully now we have like a result. Okay, it's looking like that. That's pretty interesting. Didn't I use? Oh, I rewired this guy, but not. I rewired the wrong thing. So now we have it flat. Okay, that's exactly kind of plan. And with this line, with all these points, we're gonna generate like lines, and we can rewire that into our skin measure, and then we have our level. Let's give it a try real quick. So we have 3 points here. I will visualize it using different color so we know what's going on. So that's the starting points. Gonna make it bigger. So that's our starting points, and our endpoints also I want to display it so it's pretty clear what's going on. So the endpoints can be blue color, I guess. Increase the size a little bit. So what this tree generator now is doing the hard work and generating this for us. So that's nice. We can adjust the parameters there until we get what we like, but we can also randomize the points. So you can see this is pretty fast. So far so good. We can increase the scale and let's see how far this algorithm can do the work for us. If we make the points too far, you can see the algorithms kind of stop, and we don't want that. We don't want. We can actually adjust this minimum and maximum distance, so it can go a little bit further than the usual. Let's say we make it 10, it's too far now. If we increase the maximum distance, I think this algorithm can try to find it. Although this thing will kind of die. Like imagine these three insects kind of traveling, and then if it's too far, it just die before it's reaching the points. So we don't want that to happen. I'll reduce the distance and let's try adjusting the minimum maximum distance. So that's kind of working pretty good. Maximum brands. So this also have some effects. I don't think it can go too high because there's some kind of limit in the algorithm itself. The branch length, although I think the branch length is quite interesting. So if you're increasing the branch length, this thing can go further as well. Tip radius, that doesn't matter too much. There are other parameters like tip radius, tropism. We don't care too much about that. We only care about the points and the lines actually. This can actually become kind of a complex. You can get like a complex output just simply by increasing the number of points. Let me try. So we can see, I like how interactive this is working for us. Minimum, maximum distance. I don't know if increasing it can give a better result or not. This scale, okay, scale factor can be increased. See, maybe actually more points. So we have, oh, okay. The higher the points, the target points, more points we get out of this. So that's really cool. Actually, it's kind of stop as well at some point. If it's too details, doesn't seem to work. I'm pretty sure that you can also make some adjustment to this script. If you like, just have a read at the script, and then perhaps it's there is this NBP that you can change. Instead of 2000, you can have it a little bit higher, and the number of points we can have it less or more. So it's totally up to you. So okay, that's cool. That's a tree generator for you. I think the tree generator kind of generates this pattern that's not actually overlapping though. So maybe we have to think a way to make it overlapping, but you can perhaps do this, do a couple, and then kind of combine it into one. For now, I will just use the skin mesher and then just want to see the result. Vertices, edges, kind of curious that it turn it to life, and we get this. With this guy, we can actually perhaps reduce the subdivision and we get like a more flat kind of result. This is also kind of nice. Go inside and then actually apply this. And then go inside and then scale it in the z-axis. So that's kind of generating level design as well. You can go inside and then have the character walk around this maze. Yeah, that might work. So I'm kind of curious actually with this at the moment we have, like I said, they are not actually overlapping, but you can use things like find closest KDT closest edges and plug the vertices there and try. Let's give it a try. This one kind of giving you like a pretty complex maze, so it's like more like a spider kind of web. Maybe reduce the number, increase the distance. Oops, that's too much. Maybe don't use KD3. Use another way to do this. Let's try joining mesh. Let's say we have this and then we have another one. So 1, 2, 3, 4, duplicate it and plug that in. Randomize the seed and then mesh join. For the mesh join, we actually need to list join the vertices and also the edges. So this is very much experimental and hopefully we get an interesting result. Okay, apparently we get like a pretty complex line. Probably not what we want, but try anyway. Okay, they are kind of okay. This is actually we just need a join level is 1, and let me try randomizing the line a little bit better. So we can see now at least they are kind of overlapping. So that's probably better for our level design or like a city kind of design. So with their now overlapping, let's find like a good one, like a good kind of result, not too crazy. So they're overlapping and we have like a 2 samples of this 3 generators working together. Now we just need to use intersect edges. Plug this guy in and plug this guy in there. Turn on double. Hopefully this is not too complicated for intersect edges to handle. Okay. It's interestingly take a while for this to work. Maybe did I turn on the double? Maybe I have not turned on the double either. So let's wait for a couple of seconds. And let's plug this as well. It's gonna take a while as well to recalculate. maybe we have too many intersecting lines. So yeah, like I said, you can make everything like automatically generated. Like let's say instead of using grease pencil to draw lines, you kind of have like a few vertical lines and a few horizontal lines, and kind of mix the two, and then you have the map based on that. So that will work as well. Let's bake this. Now we have this, and I believe that we need to actually merge double here. This have to be on. Merge double, and then we have to use the skin measure, and then we have some kind of form. That's gonna be for our level design. Sometimes with things like this, if the points are too close together, sometimes I kind of feel like we need to average it somehow. So if I bake it now, let's check this and check the intersection, and I think they should be connected. They are not connected, so I'll just try remove doubles here, doing it manually. Remove 738 for the Cs. Now that's actually kind of interesting. If I remove doubles, some of them now they started to make this kind of pattern. That's actually much better level design. Now if we use the skin modifier manually, we have our levels happening, and turn on smooth shading if you like, and you can also use subdiff to get a detail. Now if we go inside, we have our level. So now, I guess that's pretty cool. File, preference, input, and turn on gravity. Now if I turn on the ambient occlusions, now let's walk inside this level. Oops, what happened? Okay, I need to apply this and also apply the subdiff. Let's go inside, Shift F, and walk around. Actually, somehow it's refusing. Make this bigger. Save. Let's go inside. Shift F. Walk. Now, okay, now it's working. We can jump around. We can go inside the maze, and let's find our treasures. Or would be nice to have. I don't know. I think it's a good idea. Maybe we have like a Susan head. Place it here. Give it a red color. Go inside and Shift F, and now we are walking around, and hey, we find our treasure, the Susan head. Get the treasure. See, it's like playing game. I guess that's pretty cool. Okay, let's keep going. What else can we improve from here? I think the floor, of course, like level like this is not actually complete. It's actually only the base part. Level can be much more interesting than single floor, but I guess this is an idea. So yeah, I guess that's this is one way you can approach level design, even though it's pretty basic. And we are using this algorithm by Elfnor, and the whole thing is procedural. You can test a different level and generate a couple. So like I said, it's always a good idea, instead of making everything like using rather than making everything automatic, you want to have a little bit of control. Perhaps the points being generated can be from our grease pencil instead of making it random. But this is one idea you can approach it. So at the moment it looks like a tree design. But yeah, so hopefully this is interesting and useful. Let me know if you have any feedbacks or suggestion in the comments below. So yeah, another way we can generate some kind of level using Sverchok and Blender. Thank you again for tuning in. I'll see you in the next video. Thank you. Bye.